warm good morning, my dear students. Welcome to this chemistry digital class. Dear student, as yesterday we have started important compounds of hydrogen, in which hydrogen we have done. Hope so you understood and you enjoyed that video also. And in the similar way, we are going to talk today about the second compound of hydrogen, that is water. Water, it is well known and you know very well about this compound. It is the most precious substance in the nature that help us to survive on this earth. So if we'll talk about the water, so let's discuss. The major part of all living organism is made up of water. Human body has 65% and some plant has even 95% water. Water is one of the most plentiful and readily available of all chemicals. Almost 3/4 of the earth's surface is covered with water. It is essential to life. 2/3 of the human body is water. It has special importance to a chemist because of its ability to dissolve so many other substances. As a result, water serves as a medium in which a great variety of chemical reaction occurs. Although it is most often perceived as a liquid at normal atmosphere pressure. Water exists as solid below 0 degrees Celsius and gas above 100 degrees Celsius. The term ice and steam are used to describe the solid and gaseous state of water. Water occur in the following natural form. If I will tell you the water that is occurring in our surrounding, it occurs in the form of rainwater, seawater, surface water. Okay, in which the ocean, saline like water, and I can say sea, 97.3% of total earth, total water is salty water, in which 2.04 is polar ice, 0.61 is groundwater, lake, soil moisture, and rivers. Dear students, as we are studying about the occurrence, then we are going to talk about the structure. Now this is the structure of water. You know very well the formula of water is H2O. A single oxygen is there in the center, which carrying two lone pair and two bond pair. Two bond pair is bonded with two hydrogen molecule with the bond angle 104.5 degrees Celsius, bond order 95.7 part meter. Okay. There are two types of water, hard water and soft water. If we will talk about hard water and soft water, water that doesn't produce leather with soap radially called hard water. Leather mean it is going to be produce the missile, झाग. अगर पानी किसी सोप में झाग बनाता है तो झाग नहीं बना पाता है तो उसको हार्ड वाटर कहेंगे. अगर वो झाग बनाएगा तो उसको सॉफ्ट वाटर कहेंगे. So that which water which doesn't produce leather, that is hard water, and it is due to the presence of bicarbonate, chloride or sulfate of calcium and magnesium. Again, it is due to the presence of bicarbonate, chloride, sulfates of calcium and magnesium. Water that produce leather with soap radially is called soft water. There are two types of hardness, temporary hardness and permanent hardness. Temporary hardness is what, as the name suggested, temporary. It is due to the presence of magnesium and calcium hydrogen carbonates. It can be removed by boiling or Clark method. Permanent hardness, due to the presence of soluble magnesium and calcium in form of chlorine, sulfate, iron in water. It cannot be removed by boiling simply. It can be removed with the washing soda and Calgen methods. In ion exchange and synthetic resin method also it can be removed. So temporary and permanent hardness are two type of hardness. In permanent hardness we are using the washing soda method. Washing soda method can be convert permanent hard into soft water. There are some disadvantages of hard water, like in domestic use. Water is required for cooking, bathing and washing of clothes. In our daily life, hardness up to 100 to 150 part meter in water is tolerable, but if the hardness is more than this, the water is not suitable for domestic purpose. It is not that much useful for industrial use also, in boiling use also, formation of scales, corrosion and foaming also. So this is about the two types of hardness. Now If we will talk about the physical and chemical properties, in physical properties, the water is pure, it is poor conductor of heat, it is polar in nature, some organic compound are also soluble in water, it is colorless, odorless and tasteless. Basically, its maximum density is 1.0 gram centimeter cube, and at 4 degrees Celsius it is polar molecule, has B shape, its bond angle is 104.5 degree. Already I told it has high dielectric constant properties, it has density to associate, it is a conductor of electricity also. Whereas in chemical property, water is neutral in nature, its pH is 7, it is amphoteric oxides, and it hydrolyze and hydrated formation. Also, it react with active metals and evolve hydrogen gas. So with reaction of non-metal, it will be decomposed and it will form chlorides. Okay, so dear students, the hydrolysis is the one of the major chemical property. Whereas we will talk about the unique property of water. Water is known as liquid state under ordinary condition due to hydrogen bonding. Its freezing point and boiling point enthalpy of fusion and enthalpy of vaporization of liquid are higher as compared to hydrides. Water has the capacity to dissolve a large number of compounds, especially ionic in nature. Few of the organic compounds such as carbohydrates, alcohols also dissolve in water. Thus, water is regarded as universal solvent. This is called universal solvent. So this is all about water. Now, the third molecule, that is deuterium oxide. Today we will finish deuterium and hydrogen peroxide also. So in deuterium oxide, it is obtained from ordinary water by electrolysis, which water we have studied here. The deuterium oxide can produce from ordinary water, but if basically the the discovery of deuterium oxide is credit goes to Urey. I can say, let me write, it is Urey, Urey, who first proved that ordinary water contains one part of heavy water, in 6,000 part of it. Whereas Lewis and Donald in 1933, they were able to isolate few millimeter of the pure deuterium oxide by continuously electrolysis of water. When we are going to continuously electrolysis, suppose 2,340 liters of normal water is electrolyzed, it will give us at least 82 ml of deuterium oxide. Okay, so there is some uses of deuterium. It is used as a moderator, it is used as a tracer in the metabolic processes, it is used as a coolant also. Okay, if we will talk about the physical property, it is a colorless, odorless dielectric constant which is low than the water. On electrolysis, the deuterium oxide will convert into D2 and O2. Whereas chemically, when sodium will react with it, sodium oxide deuterite will be formed. But when we are talking about physical property, it is heavy water is colorless, odorless, tasteless as like water. Nearly all the physical constant are higher than the corresponding value of ordinary water. The comparison of physical constant and tablet ahead is there. Chemical properties, if we will talk, as I told, with action with metal. Whenever deuterium oxide will react with metal, it will form the deuterium oxide. Okay, and whenever it will react with the metallic oxide, it will form the hydroxide, deuterium hydroxide. So, dear students, these are all about the deuterium. As I told already, the uses, it is used as a neutron moderator. It is used as a neutron moderator. It is used as the preparation of deuterium. It is used as a tracer. It is used as a production. Its production is in various unit. Its production in India, especially Nangal, Trombe, Rourkela, Nampur, and Neyveli. Sorry, these are the some places where deuterium oxide is. Here, space is because of less space. Because of less space, the dihydrogen, use of dihydrogen, here, so you will note down this also. Okay, so hydrogen is used as manufacturing of ammonia and nitric acid. It is used for manufacturing of banaspati ghee. It is used in manufacturing of organic compound like methanol. It is used to reduce the heavy metal oxides of metal, used as a rocket fuel, which is very important, used for cutting and welding purpose. It is used for preparation of useful chemical. So the last or fourth compound of hydrogen is hydrogen peroxide. The formula of hydrogen peroxide is H2O2 and formula of deuterium oxide is D2O. It is discovered by a French chemist L.J. Thenard in 1818. The important chemical used in pollution control treatment. The major question, that is most important question, is coming structure. So you can see here 2 oxygen is there with 147.5 part meter. 2 oxygen is bonded, but between oxygen and hydrogen there is 95 part meter. This bond angle is 111.5 degree in gaseous phase, but in 90.2 degree in solid phase. Okay, the difference is what? In gaseous state it is little bit more bond angle here, whereas here it is less bond angle. You can see a 95 part meter, here 98.8 part meter, whereas bond order is more, bond order is less in solid. Okay, so we will make, whenever we are going to draw the structure of hydrogen peroxide, we will draw the structure like this way. Uses of hydrogen peroxide: it is used as bleaching agent, it is used for mild disinfectant, it is used as antiseptic, it is used for manufacturing of chemicals, pharmaceutical there, and it is used as an oxidizing agent also. Okay, so if you will talk about preparation in lab, it will prepare from sodium oxide, but in general it will prepare from the barium peroxide. When barium peroxide will react with sulfuric acid, barium sulfate H2O2 will give. So we are preparing this H2O2, so like this way. And by electrolysis also we can prepare this. And whenever we are going to talk about the strength, so percentage strength will be given in the gram upon ml, and volume strength will be given in ml upon ml. If we will talk about the physical properties, as usual, like water and deuterium, it is not like a colorless, odorless. It is a thick syrup, liquid with pale blue color. It means that it is colored, bitter taste, slightly base, completely miscible with water. So completely miscible with water means it is easily dissolved in water, alcohol and other dipole, because of dipole moment. The dipole moment of hydrogen peroxide is greater than water. It is soluble in water and hydroxide. Okay, if you will talk about the physical properties, pure anhydrous hydrogen peroxide as syrupy liquid. It is colorless but given bluish tincture. Its specific gravity is 1.45 at 0 degrees Celsius. It is soluble in water. It is bitter in taste. It boils at 150 degrees Celsius and freezes at minus 0.89 degrees Celsius. Okay, so here student, this is all about the basic compounds of hydrogen. Hope so you understood. Now we have done, let me recapitulate, we have done in this hydrogen chapter important compound of hydrogen, which dihydrogen we did yesterday. So you have to note down all this. We did water, we did today deuterium oxide, we did today hydrogen peroxide. Now in tomorrow's video, first thing, by watching this video you note down this chart again, photograph I am going to send you. Second thing, you make your own video if you understood by watching this video. Third thing that you have to do, that is we are doing to find out the most important question from this unit. Okay, although this unit is of 3 marks, so this is not that much length unit. One left only, that is hydrides left. So on Monday we will do hydride, and on Tuesday this chapter is finished. So till next video, take care of yourself, stay home, stay safe. Thank you. Thanks for watching this video. Thank you very much.
Chemistry of water. Water is an inorganic molecule that is the most important compound in the body. In fact, a normal adult's body weight is made up of 50% or more of water. A molecule of water has 1 oxygen atom covalently bonded to 2 hydrogen atoms. Covalent bonds being the chemical bonds that are formed by the sharing of 1 or more pairs of electrons by the outer energy levels or shells of 2 atoms. Water molecules are also polar molecules. Even though the oxygen atom shares electrons with the hydrogen atoms, the electrons are not shared equally within the molecule. This gives the oxygen side of the molecule 2 partial negative charges, and each of the hydrogens a slightly positive charge. This means that each water molecule can form up to 4 hydrogen bonds with adjacent water molecules. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. This property allows water to act as a very effective solvent, which means it is able to dissolve or break apart many other substances. Substances that do dissolve or break apart in water are called hydrophilic, which means water-loving. Nonpolar substances that do not dissolve in water are called hydrophobic, or water-fearing. Some substances, such as glucose molecules, dissolve and remain intact in water, as water molecules surround the substance, forming a hydration shell around the molecule. Some substances dissolve and dissociate or break apart in water. Table salt, or NaCl, when added to water, will dissociate to form positive sodium Na ions and negative chlorine Cl ions, with hydration shells forming around each ion. This property of water allows it to function as a transporter, as water-based fluids, such as blood, transport substances dissolved in water throughout the body. Nonpolar hydrophobic substances, such as fats and cholesterol that do not bond with water, must be enclosed within a transport protein molecule to be transported within blood. And that be the basics of the chemistry of water.
Chemical properties of water. Amphoteric nature. The ability of some chemicals act either as an acid or a base is called amphoterism. If a base like NH3 is present, water can act as an acid and react by donating a proton to that base. If an acid like H2S is present, water can act as base and react by accepting a proton from that acid. The self-ionization of water is another example of water being able to react either as an acid or a base. Redox reactions involving water. Dihydrogen can be produced by the reduction of water as given. Chemical properties of water. Hydrolysis reaction. The reaction of compounds with water to form new compounds is called hydrolysis. For example, dinitrogen pentoxide reacts with water to form nitric acid. Hydrates formation. Water form hydrates with metal salts. There are 3 main types. Coordinated complex compounds. For example, nickel 2 nitrate hexahydrate. Coordinate bond is formed between O of H2O with metal ion. H bonded. For example, copper sulfate pentahydrate. Interstitial hydrates. Water is present in some compound as interstitial water. For example, BaCl2.